welcome everyone. This is the second installment of our series of AI panels at Replit. Today we have two special guests, Chip Huyen and Amjad Masad, the CEO of Replit. Myself, I'm Michele. I'm running the AI team currently at Replit. And the topic of today will be talking about how to put large language models in production. We're going to cover both the challenges that we're all facing in the industry, but also the amazing opportunities that LLMs offer today. And I think the three of us in this panel are extremely excited and working with LLMs on a daily basis. So let's start from Chip. Chip, nice to see you again. We date back from the
Hey.
Stanford days. I'm going to give a very brief intro about you. There is so much to say, so I'm going to pass the mic to you and you can cover everything that I forgot, okay?
Okay, sounds great.
Perfect. So I think I met you while you were about to graduate at Stanford. Then you went through a series of amazing jobs. You worked at NVIDIA, you were at Snorkel. Currently, you're an AI company founder. You have been an amazing, prolific writer, especially in the MLOps area. You published last year an incredible book. I think it got 3,000 reviews on Amazon by now. So a lot of people
I
in
wish.
a lot of people in the community are really appreciating all the effort that you put there. And last time we collaborated together, I think I was one advisor in your Stanford course on machine learning system design. So really nice to see you again. Please fill all the gaps that are left in your intro.
I think it's pretty good. Thank you so much for having me. So, Michele, am I still saying your name right? I
Absolutely.
remember like when we talked about like 5 years ago, you were very excited in like using machine learning to help you write better code, understand code better. So it's really cool to see you at Repo today, and really nice to see you, Amjad. I know that we met many years ago on a camping trip. I think it was like an idiot back then. I just straight out of college. So I'm so glad that after that you still want me back on this. So yeah, really very excited to be here today.
Perfect. Yeah, no, we love to have you on board, and we're going to be talking about your recent blog post on LLMs. And that's going to be basically the focus of today's discussion. And then, we have our stable guest, Amjad, the CEO of Replit. Hi, Amjad. Nice to see you again.
Yeah, great to be here.
So Amjad, you know what? I just saw the blog recently. It was like you wrote. You usually write a lot, and the writing was really cool. I love the essays. Why did you stop?
Well, time is mostly why I stopped. It's just like been hard to find, especially running a company and having kids. Is sort of hard to find continuous blocks of time needed to, because as you're writing, you probably spend a lot of time writing your blog post, which is great, goes into great depth. Uh, you spend a lot of time procrastinating, thinking, hitting the writer block, and doing all of that, and so it just you sort of get used to being just interrupt driven, and there isn't a lot of time for like deep work, and so trying to build that back in right now, but I think it doesn't make a lot of sense for certain times during the company when it's like really intense. It's really hard to find those.
Yeah, it seems like you have to drop either the company or the kids.
Sort of, yeah.
Or it's our job to keep Amjad less busy, so he can go
Yeah.
back to writing. Yeah, yeah.
Yeah.
We're going to make that happen. No worries. All right, so let's get this started. Chip, let's talk about your blog post. I think everyone in Rapid read it and loved it. We had a lot of discussions, on our internal Slack. I couldn't see the people in person because not all of us are sitting in the same office, but I'm sure everyone was nodding when reading your blog post, especially on the challenges of deploying LLMs, the lack of LLM ops, and so forth. So why don't you let's get started by hearing your hot takes about what you wrote. Like if people have 2 minutes to take away about what you wrote in that blog post, what would it be?
So the blog post is from like mostly personal experience. I think it's like, I think a lot of people, not just me, right? When we saw all this cool stuff going on, I was like, okay, I want to play around with it, and actually have a semi brother who putting a lot of requests. Like, okay, I want this app like this. Can I do this? It's like, okay, let me try building this for him to see if this works. And so I in the process, I ran into a lot of challenges. It was like, wow, this is like I wonder if other people share similar experience. And the blog post was entirely like from talking to people, personal experience, and see like what are the common threads that I saw. It was a fun experience.
Oh, I bet, yeah. As much as working with LLMs, like joys and pains on a daily basis. Yeah,
Yes. So like at Repl, right? You work with a ton of like LLM. So I'm wondering like which part do you feel like that I missed or like yeah.
I would say a lot of the work that goes in LLMs today, first of all, is way more engineering than people expect. But I would say that applies to anything in machine learning. But I'm talking about myself, coming from academia, but I always try to have a hybrid profile in my life. Researchers expect most of the work to be writing papers and maybe, the 200 lines of code of PyTorch. And in reality, LLMs is a lot of engineering work around it and then just a tiny bit of LLM optimization. So that's definitely something that we learned the hard way internally. We recently released our own bespoke model that we trained from the ground up, so the way from curating the data, training our own vocabulary, coming up with the whole LLM, and also a very important part for us is we have a lot of users, so how to deploy it, how to have optimized inference, how to lower the latency. So maybe these are issues that not everyone is exposed. The LLM researchers see the interesting core part of creating models, but then there is a lot of work that happens after creating the model per se.
Um, can I ask a follow-up question about that? I'm always curious
Sure.
to see like the internal working of different teams when they build their models. So like how long did it take you to build that model? Like how many engineering weeks or like the cost of it? Yeah.
We talk about weeks. It's more days. No, I'm just kidding.
Yeah.
So I think we set our mind on that, let's say, a month before we actually released it. But it
Yeah.
was like a slow ramp up at the beginning. We were working on the data pipelines, we were working on the vocabulary, doing some ablation studies. And then at the point where we realized, let's make this happen, we're into something that is going to work well. And we were getting like good, promising results on the ablation studies. Then we decided to scale up, and everything happened in the matter of, I think, a week. The core model that we released open source was trained in 3 days on 256 GPUs. And I mean, that's the beauty of working with models that are not massive. So we release
Yeah.
a 2.7B. It would have not been the case, if we were working on a 7B or a 13B.
Yeah.
But it really tells you how much easier things are compared to a year ago. Now, that being said, easier probably comes from the fact that I've been doing mistakes in this field for quite a few years. So like this time it was a bit easier, but we literally went like 2 people full time on the project, and then like another couple helping us quite a bit. So
Yeah.
it's very exciting to see how accessible LLMs have
Mm.
become from for smaller teams.
Yeah,
I
the
see.
surprising thing about it was like um, we didn't know what we're gonna get. Like a lot of where the LLM world is right now is sort of feels like a little like alchemy. You sort of pour in data from here and data from there. You stir a little bit, and then something pops out, and then you look at it and like, oh, is this good or is this bad? And so the slow ramp up that Michele talked about was us actually training very small models, like 300 million parameter model, just to see like actually are we getting anything interesting out of those. You can see the loss going down, but that doesn't tell you much, right? And so you sort of have to do these test training runs. But even at the end one, which we called the YOLO run, because we were going to run this 2.7 billion parameter run and light up a lot of money on fire, essentially. But are we actually gonna get something interesting? And we didn't have a lot of, although we did these test runs, we didn't have a lot of a lot of confidence in that. Just to add more variance, I think it was the first time we had trained a tokenizer as well. So it was like a bunch of things had changed, and then the performance that we got was surprising in terms of positively surprising. It was
Mhm.
a lot better than we expected. To the point that now we're thinking, oh my god, we actually probably left a lot more on the table in terms of what we could do, and that how we can optimize the data mixture and how we can just like that, make the product better. And so we got a lot more ambitious. And the next model that we're going to train is just going to be get to be more ambitious. And that's a little tricky. You don't want to
Yeah.
adjust your ambition too high and set yourself up for failure. But you sort of want to stage it out. But then at the end of the day, I think you just need to accept that there's certain amounts of uncertainty that you're going to have to live with. And a big part of engineering, especially at startups, is that sort of YOLO mindset and fuck it, test and prod.
Yeah. That is pretty awesome. So you did one run, right, for 2.7 billion
Mhm.
per model. It's one run.
It was one
Um,
run, yes. And then we had a fine-tuning run after that with our Replit data. But even that was a YOLO fine-tuning run. So it worked pretty much out of the box.
I see. I'm wondering if that like similar for other companies. Just like, yes, we want you like experiment with this LM stuff, and we just like have one shot at it.
To be fair, I don't know of many companies having built their own bespoke models. I think I can count them on two hands perhaps today. I might be underestimating, but if you go on Hugging phase, you won't find plenty of generative causal LLMs trained from scratch. A lot of distilled versions, fine-tuned versions, that is definitely
Yeah.
more approachable today. But from the ground up is still quite a bit of a challenge.
Yeah.
And also,
I
as
see.
that said, you have the potential of lighting on fire a lot of money if you get
Yeah.
it wrong. Yeah.
I mean, like you're pretty familiar with like Mosaic, right? I wonder, like, did you consider using them for bespoke model?
We work with Mosaic.
Yeah.
We
Okay.
work with
Oh,
Mosaic.
oh,
Yes.
that's cool.
Yes.
Yeah.
Yes. Yeah. That definitely helped a lot. Like we, in a sense, we expanded our engineering team by 10x working with them. So it was a great experience. Shout out to the team once again for helping us quite a bit throughout the process.
I see.
Yeah.
Yeah,
Yeah.
it's kind of wild how fast this stuff is becoming accessible. Like I remember a year ago, we were when we were building Ghostwriter and looking at the codex prices, even for Cushman, the smallest one. We were like, we will never be able to do this. And we know how to do this. We built the entire thing. We actually like had prototypes like way earlier, but the prices were kind of crazy. And we knew because we had a lot of users. We have our customers tend to tend to be a little different than sort of say Microsoft's or GitHub's customers, and for us to price higher is not is just not going to work. And so when we went down this open source path, and then eventually building our own models and open sourcing that all happened in like less than a year, like 6 to 8 months, right? And it's just you go from a place where it just feels like, oh, OpenAI has a monopoly on this technology, to like, oh, like you can actually like hack on this in your like mom's basement in like 6 to 8 months is pretty amazing.
Yeah, that's pretty awesome. I mean, things are moving so fast that sometimes it just get a little bit like dizzying. So my friends and I were talking like we need a conference call. Like everything is so overwhelming, and just to complain and to like have like puppies and I know boba and tea and
Invite me in. I need some therapy after the experience. All right.
okay.
Why don't we talk a bit about what you're doing at Claypot, and also the idea of continual learning? I have some questions about also Replit and our models, but let's start from real-time machine learning. What do you think is becoming so important, and why are you devoting all your energies on that?
And perhaps what is Claypot first, and then we can go into that.
Yeah, so far as like real-time machine learning, I think like they can be think of it in different ways. So like one is like on prediction side, right? Like you have some requests coming in, you have some user activities, and want to leverage this information to make predictions right away, right? Like so, there are a lot of use cases that are very useful. So like fraud and scam, of course, they are like the typical example, like on the ETA estimations, dynamic pricing, but also like a lot of recommender systems search, right? Like if you see people are looking at things, you want to like look at that recent activity and help them like find the things they're looking for right now, not the things they look for like 6 months ago, right? So I think like that is one thing about online like real-time machine learning is just like online prediction, leveraging like fresh data to be able to make better predictions. And hopefully it should like make you a lot more money. And the second thing is about like how to update the models, right? So separation phase, you don't really update the model weight. You just like leverage fresh information for predictions, and then continual learning is like how to leverage these informations for to update the model weight. So especially with I'm so glad about like on this like chat GPT stuff, because it made people realize like, oh wow, it's possible like how quickly models can go stale. Like how many times you
Mm.
see put a request like, oh, as my knowledge cutoff is like September 2021, I can't really have you find anything after that. And we're like, okay, let's try to figure something out, like maybe you browsing, right? So or like you put more context into the you put more information into the context of prompt. But I think it's just like a workaround, because I've been research showing that like incorporating information through the context, like prompt, is actually doesn't give quite as good as performance if compared to like building that context into the model itself, like by retraining. So I do think just like that's why we decided to work at Claypot.
Yeah, that's great. So I'm glad you talk about LLMs at the end, because my selfish question is, and I'm going to ask you to wear your teacher hat and also your Oracle hat at the same time.
Mm-hmm.
So do you have a clue how we're going to be capable of fixing that issue with LLMs? And if yes, what is your prediction when that's going to happen? And think about our Replit model. I would love to keep it refreshed with all the code that our users generate on a daily basis. But right now, our plan is to retrain it from the ground up, say every month, every quarter, depending on how much money we decide to invest in this.
Wait, like every month?
At least this is my this is my dream. I'm sure that Amjad will
Yeah.
never approve it because it's way too expensive. But you see where I'm going. It will be amazing
Yeah.
to make sure that if there is a new library, a new framework that our users adopt, we want to immediately be capable of generating code based on that new framework. And right now, it's not the case. Our knowledge cutoff is not as bad as ChatGPT, so we are not talking about September 2021.
Yeah.
But it's still something that eventually is gonna bite us. So what do you think? What is the LLM community doing there? Like I try to read as much as possible, but I don't think there is still like a good proper solution apart from retraining and spending a lot of money.
Yeah, I do think it's like there's like an immense amount of work being like research being done in this
Hmm.
area, right? So I think like there are or one thing is like people have been like thinking of like treating the new data as just like fine tuning problem, right? So you don't retrain the base, you just like get fine tuning, and in the fine tuning itself there are like multiple things, like what kind of layers do you fine tune? Like do you just fine tune the last layer, or like several layers? And there's the idea of like adapter, like you just like inject a new layers into your model and just like fine tune on that new injected layer. So I think like there are a lot of ideas. So I'm not entirely sure how that would pan out, honestly. But about I'm
Okay.
excited. Like I feel like as you are doing that, I would hope that you could share your experience as well. What yeah.
We will, yeah. I mean, we have our eyes on Laura. I've been, hoping to see that growing, since
Hmm.
the first paper was released.
Yeah.
So I would say our bet is there. When we're still not putting too much work because I think it's still in the research phase right now, as you
Mm,
said. So a lot of research going on, a lot of promising results. Possibly there is still not the full-fledged engineering solution to make this
yeah.
happen easily, both for the fine tuning, but also for the serving, which is very
Mm,
concerning to me. Like, how do we load these layers or weights at runtime? How do we keep them refreshed? It's a
yeah.
non-negligible engineering lift to make that
Yeah.
happen.
Can
So
you,
yeah.
Chip? Can you elaborate why you think that context, uh, in context learning or context based information slash retrieval and putting in context, you don't think that's the right approach? Because obviously there's now like a context window race almost. Anthropic obviously released its 100K context length. There's a lot of vector databases, a lot of frameworks, LangChain, whatever. They're all working on this idea that the way to make transformers, large scale transformers, actually current is by efficient retrieval and in context learning. So why do you think that's the wrong approach?
I don't think it's a wrong approach, right? I think it's just more like which one is more efficient, like which one is more performant, right? So I think like an approach can still be like, yes, it is the best possible approach given like all the constraint we have. But like if we can lift certain constraint, right, like cost, for example, like retraining, fine tuning cost, then we would be able to do more. So I would think of it as like how are stages, right? So the first stage, like the hardest one, would just be like, yes, retraining the base model, and the next stage is just like fine tuning the model, and then another, like the top would just be like, okay, in context learning, like better retrieval. So, and I would say just like usually like the more you can do, like the lower in the pyramid, then the more performance you can get, but it also like cost more effort, more money, time wise as well. So that could I that's what I think I mean by the in context learning. Yeah.
Yeah, that's an interesting way of looking at it, and in terms of like which layer of the stack, and that actually, as an analogy, kind of um, it makes sense, because in software, in all sorts of software, we have this sort of analogy. It's like you don't want to change the kernel all the time, but you do want
Yeah.
to update it when there's like security fix or something happens.
Yeah.
And you don't want to ship new application layer software all the time either. But you want to be able to update the data all the time, right? And so it sort of makes sense as an analogy. Have you
Mm.
looked? Have you looked at uh, uh, there's something called vector additions, I think, where I think it's like a recent technique where you sort of inject uh, vectors into the middle of the feed forward flow. So I think it's called activation vector. You add an activation vector uh, as a way to kind of steer LLMs. Have you looked at that at all? Or what do you think of it?
I think like I've seen like several approaches deal with like vectors based stuff. So like something like in the adapter, right? You're just injecting certain vectors into
Mhm.
so fine tuning layers, but also see like prompt tuning. Like instead of like feeding the prompt as text, you can also just like get the embedding of the prompt and then update that embedding. So I'm
Mm.
not sure where this activation layer falls in. I
Yeah,
haven't heard that phrase yet. Sorry.
this is. I think this is new. It's like from some alignment researchers. I'll just put it in the comments for you to look at it later. But basically, yeah, it's like you give it a prompt, and and everything, but in the middle of it's kind of it's the weird hack. Literally in the middle of the of the sort of feed forward pass, you inject a vector somewhere at like a certain layer, and you give it some kind of weight, and somehow you're able to sort of steer or program the LM in a certain way. Um, so thinking about your analogy of sort of like the sort of the base and all the way to the top, maybe there are some ways in the middle that you can do things for freshness and programmability.
I see. I would have to look more into this. Does this update the model weights at all,
No,
or
no.
does it only update the prompt embeddings?
Only the activations. So if you think about it, when you're doing context learning, the weights are frozen. So the model is
Mm,
learning through the feed forward by changing the activation. So the activations are the new weights that learn through the in context learning. And this approach is basically injecting a vector, is like a method signature or some additional information that you give. And it's similar to prompt tuning, but is happening midway through the feed forward rather than at the beginning as an input.
I see.
They probably found out that it's even like more effective by doing that like at the random step of the feed forward rather than on the prompt tuning. But
I
the
see.
underlying concept is the same. And again, like adapters are also kind of similar. So like they inject weights basically during the feed forward, train in a different way. Um, from what we have been seeing, like empirically, is that, as you were saying before, Chip, nothing is better than retraining the old model, because it's gonna update also the weights based on the new data. But we will have to find a good trade-off between how much money we spend so often we redo the pre-training, and how much we can adapt them with more and more advanced techniques. So yeah, that's one of the fields that I'm following the closest right now. But I hope that someone will do the engineering lift to make them accessible. And perhaps we're going to be playing a role in that, because it's very relevant for us at Rapid. We
Yeah.
just want to make sure that we make the right bet, because we can't afford to do like 10 different threads in parallel.
I know you raised a lot of money. I don't know. Yeah.
We can convince Amjad during the call. No, I'm just kidding.
Yeah, so I think it's pretty good. It's like well, question back is a context length question, right? So I know it's a lot of companies like want to have longer context length, like 100,000 token, for example. And I'm always curious. It's like, yeah, you can take in that many tokens, but like how efficient is a model able to use on these tokens, right? Because I've seen some research like, okay, the longer the tokens, the model. I mean, you probably have experience as well, right? The longer the context, the model seem to like less able to like remember things from the beginning or like be able to
Mm.
process. So I'm curious, like from your experience, have you tried out with longer token length?
So we have not, but actually, someone did an experiment. I'm trying to find it.
On the 100K Anthropic.
On the Claude
Yeah, yeah,
100K
yeah.
context,
I think I've seen.
where they ran an eval against a GPT 3.5 with retrieval, and they found that they're functionally the same, except the retrieval is actually faster
And
in terms of performance, right?
mm,
So some people are speculating maybe the context window is some kind of retrieval is doing actually. Like maybe it's not actually like running attention on all of that. So I think just the community is still reacting to that. I mean, obviously, like the best case scenario is that this is like functionally unlimited, and it just gives you
Yeah.
the same performance. But what you're saying is that something at the top of the context actually the model just sort of forgets as you get down. Is that right?
Yeah, so I did try with some applications, just like do some like very local small experiment. So of course I would not publish a paper on it because I don't think like it would pass any like rigorous peer reviews. But I think like just from my personal experience, just try like yeah, I try to like get as much context in there as possible, and the model is just like get really funky. Like the response is not quite as good as like so I even see like a lot of trick will do, right, like to break the task like the prompts into like smaller tasks, like smaller prompts, and like so it can understand the instructions better when it's like shorter. So that is mostly in my experience and what I have seen.
yeah, I think I've seen also a few, again, empirical experiments where they copy paste the whole book, like a murder story, and then
Yeah.
they add, who's the killer at the end. And with Claude 100K, they kind of get into the vicinity of what would be a reasonable explanation, but they don't get
Hmm.
it right. Even if the explanation is in the context, because at the end
Yeah.
the book explains who was the
Yeah.
murderer. And to me, like, again, like chain of thoughts, or like the most recent ways of doing prompting
Yeah.
and having a better reasoning, seems to be the way to go regardless, because then you can really guide the model towards doing reasoning correctly and then giving you the right solution.
Yeah.
But nevertheless, I think I'm grateful that we are seeing models with larger context windows, because the only way to find out is to empirically test LLMs.
Yeah.
So that's how we do research today, unfortunately or luckily, depending on the point of view.
Yeah, it certainly like makes a lot of use cases possible, right? So like what if you have some real long like documents and they want you to like answer that questions, and I think like traditionally they would have long documents, right? You want to break them into like smaller parts and like get embedding for each part and then I join them together. But the thing is like large language model today are not conditioned. The generations part is tricky, right? Because the text generation is not conditioned on the join embeddings. It's conditioned on just like the embeddings of the whole thing. So
Hmm.
so I think like with our longer context length, we can't really get the whole document embedding to be able to like generate responses based on the document.
True.
So I would say that it's definitely like make a lot of use cases like this
Yeah,
can do
yeah, yeah,
without. Yeah.
yeah. I agree.
Can you say more about that? I'm not sure I understand the last part about the embedded.
So on your case, like we see a lot of people are trying to do. I'm sorry, I think like somebody. Let me close the window.
But
We hear
I,
somebody.
I, I found the evaluation I was talking about, so I put it in the chat.
Oh, thank you.
Yeah. So a lot of company we see is just like trying to do something called like talk to the data, right? Like get all the company documents. So see you're a bank and you have a contract. Or like I'm buying a house, right? And I'm looking at disclosures. And what I really want to have is somebody just look at on parse on the disclosures and just be able to like tell me things. Like I can ask question about that, right? So one approach is it's just like get put on the um like say you want to do summarization, right? Like one approach is just like get on the document into the context and say, hey, summarize this for me, right? And it could be very hard to do so without able to input on the whole document into that. So in the past, like because you could need the embedding with the whole document and then you generate summarizations based on the embedding of the document, right? So in the past, like without generation, you just care about the embedding of the document. It's possible to just break the document into different chunk, and then you have another model to take all the embeddings of different chunks and generate the embeddings of the whole document. But then you would need to be able to generate responses based on the joint embeddings. So the generation part have to be trained on this kind of like joint embeddings.
Mm,
But I think like for today language model mostly is just like generation is conditions on the embeddings of the raw text, not the joint embeddings. Does that make sense?
Correct.
hmm hmm
Yeah. So I think like approaches like a lot of companies are doing is just like it's like use retrieval. So what they do is just like and it's just like they treat each questions or like text as a query, right? So like given a long like disclosures or a contract, they could like break that into different smaller chunks and generate embeddings for that. And when you receive a query, you get the embedding for this query, and
Yeah.
then use some like files or some like affections query search to retrieve the embeddings closest to this query embedding. So and then you get all the chunks that related to this query, and then you input all the related chunks into the context and get response back. So in that case, like you do need like a lot of like context length for that to work as well.
Right. Yeah. But yeah, there's a lot of but as you said, there's like a lot of practical and theoretical consideration around context length. So what is Claypot's sort of solution to this, and what is the product going to actually look like?
So that is just a very good question. So I would say this like for us, we see the world as the future. We categorize them into two type. So once we can like own this embedding space, so embedding is huge with generative AI, right? And we consider them as like fuzzier, um, fuzzier signals, right? Because it's pretty good, but it's not really exact. You look at the embeddings, you're not quite sure like yes, what does it means? Floating points, they own just floating points numbers. And then another kind of signal is like more like exact signals. So things like, for example, like oh, how many, what is the average price of all the products this person has bought in the past hour, past month, or like how many people, how many devices this person has logged in from, or so kind of thing like kind of matter, right? Because like if you in the last if in the last half an hour you logged in from one device, it's very different from hey if you logged in from like three devices from different locations. So this kind of thing like kind of matters. So you can't really rely on like fuzzying computations, right? So I do think that for a lot of machine learning models to work, you would need a combinations of both fuzzier computations, fuzzier signal, and more exact signals. So that's where we come in. So we don't really have we don't train our own language model, right? But we do have a way for people to work with both type of signals efficiently and easy, so they don't have to switch between different pipelines.
So,
So
so what you go ahead, Mikhail.
Yeah, so you can combine then generation and or classifications for both types of signals.
Yeah.
The special sauce, the magic ingredient of Claypot, right?
Yeah. So I think that we see that in a lot of use cases, like for example, like for recommender system, right? You can have on the product embeddings. So say that if users look at on the product, like you can get on the embeddings of product, and you can generate like an embedding of the users based on the products they have seen, right? But you can also look at this like oh hey, like the price range of this person looking into, like the exact computations, right? Like the categories of the products they look into, and you need to compute that. So now if you use both of them, you can do pretty good. So you can think in a way, you can think of like embeddings. So embeddings are expensive to generate, right? You don't do it on the fly. So you can think of embeddings as a way to like of course you can, it's a certain case you actually can but I don't think it's like very scalable, like say if I look at like a lot of but I think like it's a lot of time it's better if you have like based on longer history. So you can think embeddings as uh, keeping long-term informations about someone or like about an item, and you can think of like you can use the most recent activities as a short-term interest, and you can join them to make like better for recommendation systems or search. Another thing is like fraud detection use case, right? You can think of like you can both treat a transactions as a as an unstructured data and just feed into the model and just get a back embedding to represent what transaction is about. And then you can just look at the user behavior, like okay, how many transactions the person has sent over the last 10 minutes, an hour, 30 days, or the average price, average transaction amount, like categories, and on like IP devices. And then you can use both of that information to be able to detect fraud, like if a transaction is fraud or not, pretty well. And we can have many other examples that I can go into, but yeah.
I'm just sorry I cut you off. I think you had a question.
Yeah, I was just gonna say, like, how would developers use Claypot? Like, what does it look like, the service?
Um. So one thing that's like, are you talking about like whether it's gonna be open source or it's gonna be like a managed service, or what are
Yeah,
you
is it like
talking
a
about?
managed service? Do I include it? Is it like some sort of library, or like, are you gonna do serving and training on my behalf? What, like, how would it look like?
I do think it's like there are a lot of companies. So I do think it's like as a startup, you probably experience it as well. Like you can't really do everything, right? So I do think this like as a workflow goes, people pick different part of it to focus on. For example, like some companies focus on making the inference service like really fast, like the quantization installations, like NVIDIA Trident, right? Like does the quantization pretty well. As a company focus on like the training part, training pretty fast. Like Mosaic makes it doing pretty well. So for us, like we focus on the workflows, like the data scientist experience. So as a data scientist, right, I want you to leverage different kind of like data sources, right? Some are like batch sources, some are streaming sources. I want you to leverage different kind of signals, right? Some like embeddings, some are like exact count. So they could have different like latency requirement, right? So for example, like, oh hey, if I care about something that happens in the last 6 months, then 1 day latency is fine because it doesn't make like a few hours difference. It's not going to make a big change. But if I care something that happened in the last 10 minutes, then latency is very important. So that's a guide thing. So like I would have different like latency requirement, and our experience give users like data scientists like the ability to just use of same API. So we support like both Python and SQL, and we kind of have a compiler layers, right? You write the code, and we look at your kind of computations you want to do, and we would based on the characteristic of the computation you want to do, we would kick off the most efficient computation engine. So we have a compilation layer to like compile into the code of that different computation engine. So we focus on that on the workflow experience.
Makes sense.
Got
Yeah.
it. Chip, you said you're not training LLMs, but you're using them in production, right? For
um
Claypots, or you're only encoding, or you're also generating.
we don't build our own model per se, but we
Mhm.
do our partners, our users do. So we just consider like LLMs as one way to generate signals for the workflow. Yeah.
Got it, but you don't generate that signal yourself. Your client runs an LLM on premises, and then they include it in basically in your pipeline.
So sometimes they run LMs on prem, but a lot of ones will just use like APIs. So
Got
say like yeah.
Got it. But what have been the challenges for you, like to integrate APIs? What are the pros and cons? I think the pros we all know, it's available out of the box. The cons is apart from the pricing, like what other pain points are you experiencing using APIs extensively?
Oh, so as a question about like what is a like using like API
For
like
LLMs, yeah, not in
yeah
general, of course. Yes, yes,
versus like open source model or uh
correct.
in-house. So I think I could want to throw the question back at you because you also decided to like invest a lot of money into building the bespoke model, right? So I imagine performance is one reasons, and but I'm curious to hear about like what other reasons that you want the own model.
I'll share mine. I think also
Yeah,
Amjad will have a lot to say. I Being capable of training exactly the model you need for your use case allows you to optimize it as much as possible. So the truth is,
yeah,
models available via API are extremely powerful, not only because those companies are capable of training
yeah,
such powerful models, but also because they need to capture as much market as possible.
yeah,
And for us, it's exactly the opposite use case. We knew that we wanted to get the best possible code completion at a low
yeah,
price point and a low latency, and we just zeroed in on the perfect design to make that happen. So I think that's the key reason why we decided to go with our own model. And also, it's kind of a very good teaching experience internally, to build your team and gain all the knowledge required to build your own LLM.
yeah,
Amjad, anything else that I forgot?
Yeah, I mean, no, that's right. I mean, the philosophically though, I think there's like two visions of the world. I think that is forming in the AI space. One, whereas this mega model that learns everything and is multimodal, and it's like AGI sort of vision. Um, it's served via an API. It magically understands everything you need. It's probably expensive. It's probably a little slow, but on the intelligence scale, it generates super high quality tokens, regardless of what you throw at it. Um, that's aspirationally, at least, that's what these companies are trying to do. The other vision is that LLMs are actually a, um, a sort of a new type of software component, and you'll have a lot of different LLMs with different capabilities, with different domain specific knowledge, um, and there's going to be a lot of engineering to kind of make a product work out of a lot of different domain specific LLMs. You talk a lot about latency in your blog posts, and latency is another consideration of like when will the user be willing to wait longer versus wanting to get something in the order of milliseconds versus seconds versus minutes versus days. All that sort of goes into the building of the product. And at the end of the day, I think like any sufficiently complex product could use 5 to 50 LMs. Like I think we're heading to a place right now with Replit where we're going to have 4 to 5 LLMs interacting in different ways, supporting the user in different ways. And we called it last year Society of Models. Maybe it was a bit of a contrarian sort of move last year where we said this is where we think the future is
yeah,
headed. And it turns out I think we're increasingly right. And there's a place for both. This morning I saw this model called Goat 7B that was trained on arithmetic. It was Llama 7B trained on arithmetic that beat GPT-4 on addition, subtraction, multiplication, things like that, right?
yeah.
So all of that, I think we're continuously seeing signs that domain specific sort of training is probably going to be superior for most use cases, except perhaps for the use case where you're building a consumer chatbot that could do anything, which I think is probably not what most people would do. It's mostly just like what ChatGPT is, and perhaps Microsoft Google built that.
I think it's like a very interesting so um before I answer the question, before I follow up, I think I have a lot of like follow up because I feel like we had a big debate. So I hosted a dinner recently, with a lot of like people working on LLMs, and we had this big debate about like open source versus like or like bespoke model versus bit API. So I would love to follow up on that. But quick question is like, so you mentioned it's like you care about you build this model, Ghostwriter, right? Like bespoke 2.7 billion model, but it was before something like Starcoder came out, right? So I wonder if like did the Starcoder change anything?
No, because actually the fine-tuned Replit 2.7 billion parameter, it gets close to the star coder performance and human eval. And I think generally if you try to use it, um, so performance wise, it's still very similar. But serving wise, it's going to be a lot cheaper. It's going to be a lot faster. Uh, it's a lot more portable. We have some open source hackers right now doing things with it. You're going to be able to run it on your iPhone pretty soon or your Android tablet. Imagine having a coding assistant on your tablet offline. That would be pretty
Yes,
sick.
certainly.
So
So when
yeah.
you say human eval, like what was the process like for human evaluation? Like what do they test on and how many? Like what's the process?
So it's called Human Eval. It's a benchmark released by OpenAI around
Mm-hmm.
end of 2021 in parallel with the Codex paper.
Yeah,
And it's a set of 164 problems where you have a natural language prompt in English describing, a
yeah,
relatively small problem that can be solved in Python. And then you ask the model to generate a standalone Python snippet. You
yeah,
execute it, you have a test harness, and then
yeah,
you check if the results are correct or not. So it's probably it's a human eval is possibly not the best name, especially with everything human
yeah,
evaluation that has been happening in the last year. But historically, that's how we call it,
yeah,
and that's how we have been benchmarking most of the code LLMs in the past couple of years. It's not the best benchmark out there. I think everyone in the community agrees, but someone has to put the effort to come up with better benchmarks. And it's in our roadmap as well, Rapid. But
yeah.
yeah, we are hiring, by the way. I keep saying that a year ago. So we are looking for LLM hackers that want to join us to work on these problems.
Wait, so you call it Replit and not Rebel?
It's Rapid.
Oh my
Yeah.
god! I just has because our team switched to Replit recently, and my team was like Rebel. I was like, I'm pretty sure it's called Replit, and everyone was like, no, it's Rebel. I'm so glad I win this time. But um, so yeah, so okay, so back to the bespoke model on like open source. So I think like on I feel like if we go into evaluation, it's gonna be in another can of worm. I feel like I think historically we like academic benchmarks have always been like lagging behind industry use cases, right? Like think about like like I've been so I was NVIDIA. I was very excited about ML Perf. So it was just like it takes time to build out like benchmark and it has to be an independent, right? Like the person's
Yeah.
building the model can't be the same person who has a benchmark say, hey, according to my own benchmark, my model is performing better than everyone else. I think it's really tricky. So it take a while for like the industrial ML perps, right? You look at different use cases, different model types, and they have different benchmark for like different type of models and different use cases, right? I think the same thing could be needed for like LM. So like you think so like what use cases is for, and it had to be like driven by a lot of industrial use case. But as things are still shaping up, it's really tricky. Um, so I'm very I would love to hear more like the thought on like how the evaluations process is done. Yeah,
I think the last
Honestly,
six.
yeah,
just to preface that, I'll let you answer, Michele. Like we ran human eval out of curiosity. For
yeah,
us, it was about what our users get out of it. We
yeah,
just did an A/B test,
mm,
and we did actually multiple A/B tests, one with a base and the other with a fine tuned. And users were accepting 30 to 50% more suggestions on our new model versus on the what we used before on the Salesforce CodeGen model. Also, even when we were deciding whether to go our own
yeah,
way, we A/B tested against Code Cushman, and we
yeah,
were not that far behind. And so, it is. I think the empirical answer here is like, what are the users doing? How much value the users are getting out of it?
yeah,
Um, and then we can sort of benchmarks, you know, people start cheating in kind of all sorts of weird ways. Um, like now people are like prompting before human eval, and like, why? And they introduce a new way of like testing on human eval with prompting. Like, what's the point of that? Are we just like, are we actually measuring something real, or are we just competing on measurements? And I before I used to be I used to write like JavaScript compilers, and um, the the sort of the benchmark starts out useful, and over time just gets to become almost a counter signal,
Yeah.
where if you perform really high on this benchmark, it means you just like overfitted to this benchmark, and typically you'll see things that perform really high and are really bad in real world usage. And so what you really want is to ship something and test it and see if users like it.
Yeah. Definitely. Yeah.
I totally agree. That's why we're focusing so much on user testing on our side.
Yeah.
I also believe that the last 6 months of evolution in LLMs have made benchmarks even harder to create and prepare. The reason being, how do you really evaluate chatbots? I know that we talk a lot about vibe testing, and at this point, I think it's a common term in our
Yeah.
community. The truth is, that's the only way to actually evaluate them. You open a tab with ChatGPT, one with Bard, one with Vicuna, and you just play with them, use the same prompt, and get a feeling of what kind of answer they give you.
Yeah.
And with code is the same. Like unless we build something way more powerful than human eval, the
Yeah.
best way to evaluate is to put it in front of users. So I think the LLM community is really pushing the testing prod philosophy. I know we'll make a
Yeah.
lot of people shiver, a lot of our people listening to us, but yeah, that's how things go right now. And
Yeah.
by the way, speaking of people listening to us, so I think we have a few minutes left. So I would love to take some questions from the community. Thanks for everyone who sent amazing questions on the hashtag Replit AI on Twitter. We have, in the last few minutes, I would say any reputable panel on LLMs has to talk about hallucination. Otherwise, we're going to leave people disappointed. So,
Is it possible to like go back to what just said about society of models?
okay, let's do that.
Yeah.
Yeah,
Yeah.
let's have a quick fun there. Yeah.
I thought the idea was very interesting because I feel like we keep going back and forth with being like trying to make a general models, right? So I feel like in the past we started out with like, okay, H model for different tasks, a model for sentiment analysis, a model for translations, a model for summarization, and now we just have all of these tasks in, right? Like we just like, yeah, transfer learning is the way to go. But it seems like you're saying right now, okay, now we have this like massive general model, generalizable across tasks, but now we want to like fine tune for like different domains. This is just me, but can't hear. I'm
Oh
sure.
yeah, no, I was muted. I was muted.
Sorry.
Yeah.
So, I think, look, I mean, we approach things from an engineering perspective, right? And we try not to be dogmatic about things. I agree that the promise of pre-training was that you actually do it once. We call them foundation models because they're
Yeah.
supposed to be foundations for a lot of different things. But the reality of the situation is what we're finding is different data mixtures yield different results. People will have different tastes around how to mix the data. It's just its own alchemy and art right now. So I think there's going to be a lot of different pre-trained models that have different sort of strength and weaknesses. I think there's going to be models pre-trained that do one specific things, like ours. And by the way, you can still fine tune our thing and make it like generate tests or make it do shell suggestions better or whatever. And again, you're still going to have the Palms and the Geminis and the GPT-4s and 5s of the world, and they'll continue getting better. But for people who want to build and ship product, the question is like, what is the latency? What is the cost? If there's a user query that comes in or a user action and you can do it with 90% or 99% less cost and latency, why wouldn't you do that, right?
Yeah.
um the thing you're adding on is it ends up being like more engineering costs and more maintenance costs, because now you're going to have some kind of like routing layer or some intent classifier or something that does pre-processing. But honestly, that's already what's happening. Some of the best LM applications out there are already figuring out doing that. And even, when we talk about retrieval, that's what's happening in retrieval. We're embedding the query, running similarities against some index, and then like putting more in the prompt. Uh, so in some sense, there's already sort of that happening. Um, and really the goal is like, how do you build the best product? And in my opinion, uh, currently that's the best way to build the best product. But I'm happy to be surprised if GPT-4 sort of 10x's in speed and 10 to 100x in cost, then maybe that equation changes.
I see. So it seems like there are a lot of decisions a company would have to make as they embark on this journey, right? Like whether like trimmer from scratch or get a base model. If using a base model, what base model to use, and then if fine tune, like what level of like fine tuning, like different domains or different tasks. It seems like quite a lot.
Yeah, it's a lot. And I think why companies like yours are very important in this space. And there's a lot of tooling to build. A lot of times you would want to, you know, I think the end scenario is sort of something like, I have a model, and
Yeah.
I might want to do RLHF to it. I send you my weights and my data, and I get
Yeah.
back into the model, right? And there's going to be a lot of different services, a lot of startups building that. So
Yeah.
this is explosion in um, sort of free market activity to solve these problems.
Yeah.
And I think the average developer would not have to learn all that stuff,
Mm.
going forward. And it's the same way that the average developer at this point doesn't even know what computer they're running on when it
Yeah.
comes to their, running web software.
Yeah. Actually, we're just a Tom. I feel like this is really interesting discussions. Do you think like I can follow up, like do like more in-depth chat? Because I do think it's like I'm thinking I'm writing about something. I think we didn't touch a lot on like open source versus API, because of course there are other issues like data ownership, right? Or
Yeah.
like inference service. I think like or say something in between, right? Like you can fine tune on your own data, but you can have somebody else to like host or fine tune model and like do own the optimization for you. Or like evaluation. Do you think I would love to like just chat more and like
Yeah,
write something up? Yeah.
there's a lot of really cool companies spinning up now to do evaluation as well, and that's very interesting. But yeah, happy to continue the conversation. Um, we can do one or more of these things, but we're also increasingly doing events at our office, and we want to create a sort of a community here in Silicon Valley.
Come to visit us. Yeah, we're always here.
Yeah. Okay. That sounds great.
So we're right on time. Thanks again, both to Chip and Amjad. A very exciting discussion. I hope, everyone, all the listeners enjoyed it. Thanks for attending. Let's follow up on Twitter. You can find Amjad, Chip, and I there. So any question that we weren't able to address today, ask us. We're more than happy to keep talking. And if you want to try some of our LLMs at Replit, check Ghostwriter, register for Replit Pro, and then you will get access to all the cool LLM features that we've been building in the last few months.
Yeah.
Thanks,
I mean, you
everyone.
guys have great user experience. Thank you so much. Have a
Thank
great
you.
day.
Thank you.
Bye.
Bye. Bye-bye.